All right. So the homework for last week again was to basically do some dice rolling. This was a little tricky because there wasn't something in the book directly that would be like, hey, this is how you actually roll this many number of dice. There was stuff in the program to ask, how do you roll a dice with this many sides? We actually did one in class, so hopefully that was pretty straightforward. This was the first time you kind of had to think logically about how you can roll one dice, but a lot of programming is all about like, hey, I want to do one thing and I want to do it over and over again, right? So we learned all about loops. So now we have to ask, how many times do they want to roll the dice? So let me go over the homework with you guys, and I'm going to share with you how I would solve this. If you guys have other ways that you tried to solve it and didn't work, let me know, and I can go over that here in class. And then I'm going to give you guys some lab work in class to do some practice based on more loops. Okay? Any questions on this? Did anyone have problems with the second part of this, which is asking for which dice they want to roll? Okay. I'm going to show you guys two ways to do number 2 as well, because I asked you to write it so that you could either ask for a D4, a D6, a D8, or a D20. But there's also another way you can do it by asking for any number of dice. What if I want to roll a D100 or something, right? Okay. So I'm going to start off with an empty project, just like always. I'm just going to add a new CPP file. And the first thing I'm going to do is the usual, what we call boilerplate, return 0. If I could type return 0. That's it. That's all I'm going to write. And I'm going to control, there's a shortcut you can hit. You hit Control-Shift-B. Control-Shift-B is the shortcut for building the whole project. You can also go under Build and Build Solution. You build so many times that I hit Control-Shift-B all the time. And then I'm just going to run the program by hitting F5. And you can see that it actually runs. If I put a breakpoint here, my little window comes up and nothing happens. That's the first thing I want to do. I don't want to do any work until I get to this point where I've written what's absolutely required for this program. Okay? So I go back to the homework. It says I am asking for whether they want a D4, a D6, a D8, or a D20. So as we talked about from class last week, the way that you can generate dice rolls by using random numbers. And hopefully you guys used the random number program from last week as a starting point, because there are files in there that are actually pretty useful. So I'm just going to open this guy up here. Because there are, what I would like to do is, before I even start on this homework, like getting into asking for it, I just want to get it rolling one dice successfully, right? Because I don't really care how many dice I roll. I just want to have this stuff working. So I'm actually going to start with just taking this stuff and re-implementing it on my homework. So we can just take this guy here, put it here. Notice if you actually copy, you need to copy all of it, so you can just copy all of this stuff too. Okay. So this is just the program from last week, which was the dice rolling program. I'm going to go over it line by line again. This again is how you seed a random number. Remember how I had actually typed in a number here? This was like, I typed in a random number that I just chose here. You need to actually put in something that is going to be different every time you run the program. Otherwise, your random numbers aren't actually going to be random. They're going to be the same. This is the magic line right here where it generates a random number for you. So it tells you it's going to generate a random number. This number, again, can be anywhere from 0 to 32,000. This is actually a really large number, typically. And here's where the magic actually happens, where you get to take that random number and use the modulus operator to convert it from a large number to be a number between 0 and 5. Because modulo 6 gives you back, no matter what number this is on the left, modulo 6 gives you a number between 0 and 1 minus this number that you're modulo by. And all you do is you add 1 to it. Now you get it from 1 to 6. If I didn't have this here, my dice roll would always give me either 0 through 5. So instead I want to bump that up 1, so it gives me between 1 and 6 instead. All right, so I'm going to compile this just to make sure it runs. I rolled a 1. Cool. See what I get here. I rolled a 2. I rolled a 1 again. And you can see that it's basically giving me random numbers. Just for the sake of demonstrating what this gives, I'm just going to do this like this. This is not how I would actually approach the homework. I'm just going to show you guys that the random numbers are all between 1 and 6. Let me change the font. All right. Can you guys kind of see that the random numbers are between 1 and 6? Right? Okay. What if I want to roll a random number between 1 and 20? All I have to do is change what this is right here. This is kind of like the magic dice number, the how many sides you want to roll. So if I run this now, you can see my random numbers are now going between, I see a 3, I see a 1, a 19. See if I can find a 20. There's a 20 right there. So this is a classic 20-sided dice. I'm getting all these random numbers between anywhere from 1 to the number that I chose. So this right here is the magic sauce. This is how I choose how many sides are on my die. Okay, so let me just undo this for a second. How would I take this and make it more like Diablo? Like, let's say I have a weapon in Diablo. Let's just find a weapon from Diablo here. Someone give me a legend. Fury. What's that? Thunder Fury. Did someone say Thunder Fury, Blessed Blade of the Windseeker? Okay, let's take this one here. Okay, do you guys see this? Do you guys see this range here? 981 to 1490. How would we get a number between these two? How do we change our dice program right now to roll between 981 to 1490? It's the same exact program, but it's just a different set of numbers.
You have to subtract 981 from 1.
Yep, so I take 1490 minus 981. So it's a range of 509 damage, right? So I want to roll a 509-sided dice, right? And then I want to add 981 to it. That'll give me some random damage, okay? So why don't we try that? I know that at the very least, bare minimum, I'm gonna do 981 damage with this weapon for fire, right? Oh, I'm sorry, I'm looking at the wrong number. This number on the right is actually the range of damage that you can get. This is the actual damage that I'm doing here. Let's use this one here, 1176. So I'll take 1423 minus 1176. So this thing has a range of 247 damage here. And the base damage is 1,176. So how do we get our dice roller program to do basically this amount of damage? So I know that the split is 247. So I'm going to roll 247 here. And then the base damage is 1,176. Okay? So let's just roll some D3 damage here for our Thunder Fury. So those are damage numbers that you can get. Imagine that every time you swing your sword, you're getting one of these damage numbers, right? So even though I'm technically rolling a die, our die has some number of sides, the concept is really doesn't need to be limited to like the physical representation of a die. This is all this is demonstrating is that this is how you get random range between numbers, right? You have a damage min, you have a damage max. So here, we know that this is the damage min. This is the minimum damage I can do. This is the maximum damage I can do. So this is how much our value is. So if I'm going to take a little bit of a tangent here because we're on this track as well. What if I had a variable called min damage equals 176, and a variable called max damage equals, what was that? 1,423. I can actually use these numbers to generate this. So I've created two variables here, a min damage and a max damage. It doesn't matter what these two numbers are. How do I get, thanks Adobe, how can I change this to use min and max damage? Because this is in every RPG, right? Min and max damage. Or there's like min HP for monsters equal to 10. Maybe you have random HP for monsters. Max HP equals, I don't know, 50, right? You want to generate some random value of HP between those two. Same thing for here. I want to get some damage in between these two. Can someone tell me how I can take these two variables and replace like this and this with these two variables here to get a random roll between those two? Okay, so how about we start with this one? What does this one get replaced with?
14.
This one gets replaced with 14.
No, 14.
14, 23? Wait, that doesn't make... How do I replace this with the variable that I have up there? Min damage, right? Okay, cool. So there's min damage up there. Now how do I replace this using these two variables up here? What does this turn into?
Max damage.
It's not just max damage, right? It's max damage minus min damage, right? Because that's what is max damage minus min damage here?
Oh, it's the
The
variable.
247?
Yeah, it's 247, right? So why don't I just take max damage minus min damage? So that right there, that is the damage calculation formula used in Diablo, right?
You fix it.
Yeah, it's all good.
You just need to do the parentheses for the last min damage.
Oh, you mean here? Yeah.
Yeah.
So does this make sense? So what do I get as my dice roll if I have between, oh, I don't know, 40 or 50 and 42? So what is the range of damage here? How does this work? So if I take this, if I take these numbers, I take 50 here minus 42 plus 42. What does this turn into? 8? And so now I get a dice roll between 42 and 42 plus 8. Okay, so that's a little tangent. So I'm just showing you guys the application of this. We're rolling dice, but this is also how you do rolling damage, right? So when you're playing any Pokemon game or any Skyrim game and you're trying to figure out how much damage you want to deal, you usually do it in terms of this. You specify min and a max damage, and you put that in the formula right here. Okay. All right. So going back to my 6-sided die, so I'm going to get rid of this loop here because I'm not there yet. And I already showed you guys how to get how to actually just roll one of these dice. So now let's ask which one of these dice that they want to roll. Okay? So the first thing I'm going to do is I'm going to say, hey, what sided die do you? 4, 6, 8, what did I say?
20.
8, 20. What if I did it like this? What sided die do you want to roll? Okay. What if they typed in that? What do I get? That's not a valid choice here, right? So I think we need to make an if statement that decides whether or not I'm allowed to roll. Because I asked you guys to ask for 4, 6, 20, whatever, right? Why don't we start with assuming that they want to roll. We're going to do this. If num sides, how do I decide whether they chose one of these valid options or not? If I have an if statement here, I could do if num sides equals 4. I can set up an if statement that does that. I can also say if num sides equals 6. I could use a switch statement here, though, too, right? Did anyone use a switch statement in their conditions?
I tried.
Tried? Okay, there's a lot of ways to do this. I'm going to kind of go over a few of them. Let's start with a switch statement, and then I'll go to if-else statement, and then I'll go to another way you can do this without using either of those. Okay. So what side of die do I want to roll? 4, 6, 8. What if they don't type in? Let's just don't worry about the case where they don't type in anything. We'll start with super simple here. I'm just going to get back to that switch statement. How do I take the number of sides that they typed in and use it in my dice roll here? I just do that, right? So without any error checking. So now I'm asking for them to roll maybe a 20-sided die. Let me make sure that I don't stop. I'm just going to type in 20 here. I rolled a 17. Cool. Another 20-sided die. I rolled another 17. Let's try this one more time. Rolled a 3. Seems pretty legit. If I do a 4-sided die, I rolled a 4. If I rolled a 1-sided die, I rolled a 1. Another 1-sided die, I rolled a 1. No big surprise. What if I wanted to do? These are all not things that I'm asking for. You guys know how to do a coin flip in a game? Basically true or false. You just roll a 2-sided die. You roll a 2-sided die, which is just a coin. And if your 2-sided die comes up as 1, it's true. If your 2-sided die comes up as 2, it's false. Okay, so we now know that we can ask for the number of sides and we can stick it in here. Problem is that they can type in whatever they want to. I can roll that many-sided die and I get that number back, right? While that may be useful, that's not actually what we want. So the question you want to ask is, what do you want to have happen if they don't type in a number that's valid, right? You want to keep asking. You want to set their computer on fire. It's the only way to be sure. You kind of want to keep asking them until they actually type in a valid number, right? So in the book, we had an example like this. You guys remember there was a program that was, let's see here. It was, play again. Do you guys remember this program here? This one's the same one, just with a do-while loop. So the idea is that why don't you just keep asking them until they actually pick something valid or not. So the trick here is that you're going to do a do-while loop. I'm just going to pick true in there for now. So you guys remember what a do-while loop does, right? This thing will repeat. Let me turn on the line numbers here. A do-while loop is the same thing as a while loop. Only thing is you're guaranteed to run what's inside this block of code at least once. So all I'm doing is I'm wrapping the, hey, what side of die do you want to roll, over and over again. And right now, because of the way it's set up, I have a while true. This thing will loop infinitely. So I can ask for 4, 5, 10, 20. I can type in anything. And sometimes if you type in letters, that's also bad. But now I'm asking, now I know that I can ask all the time. Only problem is I'm never able to get out. Even if I type in a valid set of numbers here, it's not letting me break out a loop. So how do I get it so that it actually lets me know whether I typed in something valid or not? It's by changing this right here. Why don't we do the simple thing first? Why don't we let you say if while num sides is not equal to 4? What does that mean? What does this actually mean right here? When will this loop stop? When does this loop actually break? When I roll a 4-sided die?
You roll a 6, 8, or 20.
Well, what happens when I roll a 6? Is 6 not equal to 4?
True, it won't work.
Yes. So does that mean I keep looping or not?
No.
When does this thing? Let's actually put a breakpoint here and let's step through what actually happens. So let's just say I roll a 6 here. Okay. Okay. So this right here, num sides is equal to 6. Right? 6 is not equal to 4. Is that true or false?
True.
That's true. Okay. This loop says it's basically the same as if this said true right here. So it's going to keep looping, right? So I'm going to step. It's going to go back up to line number 13. Cool. What if I typed in 20 here? Same thing. Is 20 not equal to 4? That's true, so it keeps going. Okay, what if I type in 4 here now? It's kind of weird, but is 4 not equal to 4? Tell me, is 4 equal to 4 or is 4 not equal to 4?
It is equal to 4.
It is equal to 4. So what does this thing actually say?
You're going to break the loop and you're going to roll the dice.
So this is false. So you gotta have to take this step at a step. I know it's a little bit like it's a little bit weird, right? Because you have all these like kind of weird conditions. So this loop, you have to remember when does this loop actually repeat? As long as the stuff inside the parentheses is true, right? As long as that's true, it's going to keep looping. While this expression is true, keep looping. So as long as that thing is true, it keeps looping. And you have to know that 4 is not equal to 4. Is that a true or false statement? That is a false statement. Right? 4 is not equal to 4. 4 is 4 not equal to 4 a true statement or not? That's a question you have to ask. If I just do this, you have to say, is this true or false? And as soon as that thing turns false, that's when you break out of that loop. Questions on that? Is that confusing to people at all? Is that a little confusing? Okay. So I broke it out of that loop. And now I rolled a 2. Okay. How do I handle all the other cases here for all the other dice that I want to roll? I can want to compare multiple types of conditions here. So here's one way we can do this. And I can show you this way with a while loop as well as with using the break and continue statements. So let me show you one way we can do this. You can do while num size is not equal to 4 or 6 or 8 or 20 because all those are actually okay as well. So if you remember, this operator, the double, it's called a pipe, can be used to say if any of these things are true, then the whole thing is true. We can also use this, which says all of these things have to be true for this thing to be true. Right? So which of these things do I use? Do I use this one or do I use this one?
The or. The and won't work.
Are you sure? Is everyone sure? Think about this carefully.
One.
You guys want to try it with or?
Yeah.
This is not right, by the way. But I'll show you why it's not right. Let me I'm going to move these all to be a little bit easier to see. Okay, so let's run this. I'm going to put a breakpoint in here. Wait a minute. I'm typing in 4. 6. Oops.
Computer crash.
That's fine. It's all good. Typing 4, 6, 8, 20. Why am I not breaking out of my loop?
Because you put them all to not equal. No matter what, as long as you're entering one of those numbers, it's not going to work.
That's right. Well, it's actually more the opposite. Like, remember that or statement here. The way this thing works is that if any of these things are true, the whole thing is true. So if I type in the number 4 here, let's just plug it in here. If I type in the number 4, this is where it gets, let's just do this. How many of these things are true? Out of these 4, how many of them are true? 3 out of 4 of those things are true. Okay. What if I type in the number 5? Let's see. If I do 5 here, how many of those things are true? All of them are true. Is there any number that I can type in that will make all of them false? Will there ever be a case where all 4 of them will be false? No. And that's the problem, is that this or means that as long as any of them are true, the whole thing is true. Okay? Let's do a couple exercises here. So this is the correct answer, because now this says all 4 of these have to be true. In order for it to be true. Okay? What if I type in the number 4 here? How many of these things are true? How many of these things are true? If I type in 4, this is true, yep. This is true, yep. This is true, this is false. Yeah. It's kind of weird to think about this, right? This is like, how about I make it a little bit easier for you? Let's do this. This is not correct either.
Technically, you just said they're all true. You're saying 4 equals 4.
No, I'm saying is 4 equal to 4? Is 4 equal to 6? Is 4 equal to 8? So there's 4 different things that I'm testing here. How many of these things are true? This one is true, this one is false, this one is false, this one is false. Right? So the whole thing is false. The problem with this, what if I type in 5 here? How many of these things are true? This one is false, this one is false, this one is false, this one is false. This, the double ampersand, means that every single one of these things has to be true, otherwise I'm going to keep going. Okay? So the right way to write this is like this. This is how you get this thing to loop until you actually have all the right sides. If I run this now, let's just run a few test cases here. I want to roll a 5. How about a 19? How about an 18? How about a 4? Okay, so it broke out. Let's do this one more time. I'm going to roll a 19 here. So num sides is 19. Now remember, this thing has, all 4 of these have to be true for me to ask it again. Okay, all 4 of these conditions have to be true. In this case, when num sides is 19, all of these are true. All of these expressions. 19 is not equal to 4, true. 19 is not equal to 6 either. 19 is not equal to 8, and 19 is not equal to 20. Okay, good. All 4 of those are true, which means go ahead and keep looping. Okay. If I simplify this, again, back down to what it was before, this is what we started with, right? This thing has to be true in order for us to pass. Let me make this a little bit more, this is how I could do it as well. Let me make this a little bit more simple. Is 4-sided die. I'm going to make 4 variables here. Okay, do you guys see, can you see those variables that I'm making? I'm making them as bools. How can I tell if it's a 4-sided die if num sides is equal to 4? Does this make sense here? Forget about this right here. How can I tell if it's a 4-sided die if the number of sides is equal to 4? Does that make sense? How can I tell if it's a 6-sided die? Okay. So now I have these things. Each of these things will be true or false based on what I typed in. Let's start with the simplest one here. I'm just going to delete this for now. What do I put in here to make it keep asking if I'm not rolling a four-sided die? What's the expression in here? How long? When am I allowed to break out of this loop? If they didn't type in a four-sided die, right? If they didn't put in the number 4, keep looping, right? How do I say, using this variable, if they didn't type in a number 4? Like, what happens if I just do this? Oops. I'll do this. Oh, let me do this here. Declare this variable outside here. We're just moving this to be like this. What does this mean? How often will this thing loop?
When is a four-sided die?
Yeah, so if I type in the number 4, is it going to loop? Yeah. So that's actually wrong. What do I need to do to make this thing exit if it's not a four-sided die? How do I reverse something again? How do I reverse the result? Exclamation point, right? Okay, so let me just clear all this stuff out. So let's take a look at our while loop. So basically I'm saying, hey, this variable is equal to whether they had typed in 4 or not. And if they didn't type in 4, just loop again. Okay, so let's see this in action. I'm going to type in 5. Okay. Is four-sided die? Whoa. The number of sides I typed in is 5. So is this going to be true or false? That's going to be false. So I get down here. It says while. Remember, this is false. Loop. So it repeated itself. I'll type in 8. Is four-sided die? Is this going to be true or false? False. So that's going to be false. This is the same as me doing this. You can do that, by the way. You can do not false. So how many times will this thing loop if I just kept it like this? It would be infinite, right? It'll be like as if I typed in that. So we can use this like that. So if it's not a four-sided die, keep asking for dice. What if I had more variables here? Is six-sided die. How do I do this one? How do I add that condition? So while it's not a four-sided die, so if I asked you, like, what would in English, how would you say it? I would say something like, hey, keep asking for the number if it's not a four-sided die and it's not a six-sided die, right? So now I can say if it's not a four-sided die and it's not a six-sided die. I'll put these on separate lines here so you guys can see. So if it's not a four-sided die and it's not a six-sided die, that's how this thing loops. So as long as it's not one of those two things. Questions so far? I can go through more examples. I'll do more. So I can keep following this pattern here. Like that. Okay. So this is how we could set it up. This means if it keep looping as long as it's not a 4-sided die, and it's not a 6-sided die, and it's not an 8-sided die, and it's not a 20-sided die. It doesn't mean that it needs to be all of these. It means that it has to be at least one of these things. Otherwise, I'm going to keep going. Okay. Here's another way we can do the same exact behavior without putting all this stuff in here. So I showed you guys how to use the logical AND to combine things. What if I did a true here instead? So why don't we do this? I'm gonna basically make this a little bit lengthier, like a little bit more wordy, but hopefully a little bit more clear too. I can do this. If it's a 4-sided die, do you guys remember the command you can use to break out of a loop? Break. Cool. So if I just do this, this also works. Now if I type in 5, this never goes in here and it keeps looping. If I type in a 4, this is going to be true. 4-sided die is true. So I'm going to go in here and break, and then it's going to jump down to line number 35. Okay. So you can set up an if statement in there as well. And then you can use all the other conditions in here. So I could do, I have my four variables here. So I could do else if is 6-sided die. How many people use an if-else if to break out of here? Okay.
I do.
You can do it like this too, right? Break. The nice part about doing it this way, that I can break in each one, copy paste, but I can also say else, say up, please enter a valid number of die faces. Like that. So I can say if they didn't type in any of these, I can actually give them an error now. So if I roll a 5 here, please enter a valid number of sides, cool. Roll that. 3, 2, 4. So there's our program. Now we have it comparing all of these. And here's a trick too. I don't have to actually make a variable for each one of these. Why don't I just take this like this? If I do it inside the if statement like this, I don't actually need to do all this at all. And that works exactly the same way. 4, 6, 8, 20. Same exact results. Cool. I rolled a 4. You can even combine it again. You don't even have to have it be this long. Notice I'm doing 4 different breaks. I'm copying and pasting. So I can use one of the other logical operators to combine all these. How would I combine all of these different if statements together? So I'm either going to be using this or this. Or, right? So if the number size is equal to 4, everyone's just saying all of them. If the number size is equal to 4, or the number size is equal to 6, or the number size is equal to 8, or the number size equal to 20. This is another way you can do this. I could just delete all these. And now I have one if statement. It's chunky. It's got all these here. And you could write it like this. This is also the same. So your if statement can look like that. So if it's equal to this, 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 or this, go ahead and break. We can combine them all like this. Okay, I'm going to show you one more way to do this. You know, I'm not going to show you that because you can do this using continue as well. I think this is more than enough here. Okay. Does this make sense now? You can do it this way? There's a lot of different ways to do it in programming. What are some other ways you could do this? Did anyone do it differently to choose the number of sides? Some of you guys I know probably use variables, right, like this. Okay, so let's get to the actual meat part of this program. So now I can actually make sure that the number of sides of dice that I'm rolling is either one of these 4. I get down here, and how many times do I roll this? I roll this once, right? What if I want to roll this thing a bunch of times? How do I have this thing roll it an infinite number of times? I just can wrap this whole thing in a loop, right? The way I like to break this down, I like to start with something that I know will work. So I'm just going to do an infinite loop here. You can tell that's actually rolling numbers here. What's weird is that, look, it's going 2, 1, 4. It looks like every second it's picking a new random number. You know why? Because every second we're seeding the random number generator again. During the loop, we're seeding it again. This seed here that we're doing, we should be doing only one time. Because if we do this inside the loop, it's actually going to generate a random number based on a seed that changes every second. So now I get random numbers here. So now I have infinitely looping random numbers. Okay, let's get to the tricky part here. Hopefully you guys were able to at least do this, which is to roll it. How do I have this thing loop just a certain number of times? Right now it's looping forever, right? How would I make this thing loop like 10 times? Let's just say 10 times. I'm just going to make it 10. I can't just put 10 here. I wish, right? That's not the way programming works. That actually will still loop infinitely.
Make a
Don't say for loop.
no.
That doesn't work.
I was gonna say make a number just loop variable, and at the end of the loop do the variable plus plus.
Sure, we could do that. Why don't we keep track of, like, you guys ever pick like Yahtzee or yeah, let's just say I had some dice in my hand, right? Let's say I had 5 dice in my hand. And I have 5 dice. I'm going to take one, I'm going to roll it. How many dice do I have left? I have 4 dice, right? I'm going to take one out of there, roll another one. I have 3 dice left. I'm going to keep doing that until I have no more dice left. So why don't I create the same idea here? The same idea of how many dice I have left in my hand. Okay, because that's basically what I want to do. So why don't I create a variable that says num dice in hand. I'm just going to start off with 5 here. Okay? That's how many dice I just want to roll. I just want to roll 5 dice. How would I make this thing loop as long as I still have dice in my hand? What is the expression I could type in here?
The num dice in hand is greater than 0.
Well, num dice in hand is greater than 0. Perfect. That's exactly right. As long as I have dice in my hand. Does this make sense? I'm going to start with 5. And as long as I have dice in my hand, I'm not done yet, by the way. This isn't the whole loop. I was just saying this. I'm doing this part at a time. This is how I would have this thing figure out when I'm done rolling dice. As long as the number of dice I have in my hand is greater than 0, go ahead and do this. Now, this is the part where I roll my dice. How do I reduce the number of dice in my hand?
Num dice in hand minus minus.
Num dice in hand
Minus
minus. So now every time I roll dice, remember, I'm going to reduce the number of dice in my hand by 1. Now my loop will loop 5 times. So I'm going to roll 4. You're going to see this how I'll put 4. Or 5 times. So see, it stopped now. 1, 2, 3, 4, 5. 1, 1, 4, 3, 1. What if I roll a 20-sided die? Okay. 9, 3, 18, 8, 6. These are basically 5d20, right? Okay, now I know that I can keep track of how many dice I have in hand. How do I make this thing something that the player can type in? Right now I have this thing hard-coded. just C in, right? If I just have this variable here and ask, how many dice do you want to roll? I could just do C in num dice in hand. Okay, so that now our program is almost done. I'm going to roll a 20-sided dice. How many dice should I roll here? I don't know.
2.
2. 10 and 18. Well, let's roll something more like, I don't know, 13. 13 dice. Okay. Does this make sense how this while loop works? How I approached making this while loop? I started off with something simple. Like, I didn't even care what the user typed in. I just literally typed in a number in C++ directly. Okay, now how do I add up all of these numbers? How do I keep track of what I actually rolled and print that out when I'm done? So how would you do it? Like, let's say I'm rolling 5 dice in my hand. I roll 1, it rolls a 19. Cool. In your head, you're like, okay, he rolled a 19. All right, you're the DM basically in a D&D game. Then I roll another 1. I rolled a 7. How do I keep track?
Store it in a like roll result.
Sure. But you're adding it in your head, right? Like you take 18 plus, okay, so 7, so it's 26. Okay, you roll another 1. I rolled a 3, right? So 29. You're basically keeping track of it every time he rolls. You're adding it to an internal number that you have. Let's do the same thing here in programming, right? Let's start with total. What should we call this variable here? Total result. Let's store it as an integer. It's going to start off at 0. So how do I add to that number every time that he rolls a dice? Where would I put that? Where do I add up the number of dice? How about every time I subtract one of the dice from my hand, I take the result here plus die, like that. What does this mean? This starts off 0 is equal to 0 plus whatever I rolled. Then it's going to loop. Why does this work? Because this total result here starts off at 0. I'm going to add to it every time. At the very end, after I'm done rolling all my dice, I'm going to roll 5 20-sided dice. So that added 10 plus 4 plus 7 plus 6 plus 3. 30. And that's the total result that I got. Let's see what that looks like when I'm running through it in code. Let's just take a step here. I'm going to put a breakpoint right there. I'm going to roll 20. I'm going to roll a 5-sided die. Okay, so total result right now is 0. I have 5 dice left in hand. I'm just going to stack this guy right here. So I'm going to step. Random number equals 1,871. My dice roll is 12. I take my number of dice in hand. I subtract 1, so now I have 4 dice left in my hand. I take 0, which is total result, plus the result here of die, which is 12. So now total result is 12. Cool. Start over again. I roll another die. This one is 8. So I subtract 1 from the dice in hand. I'm going to take total result, which is 12, plus 8. That's 20. Keep going. Die is now 18. Okay. 55. And the final result is 67. So now I have no more dice left in hand. And then my total result is 67. Okay. Okay, does that make sense? Like how you add it? All right, so let me roll this into the lecture I want to talk about real quick. So there's a difference between me putting this right here, which is my variable declaration, and me putting it right here. C++, there's a difference between these two places, between line number 35 and 38. You mean get rid of this one and put it here? There's no difference. This is the same. Like I can put it here and here. These are fine. Why do you think this makes a difference when it's inside those curly braces there?
Because it's only for that step.
Yeah.
Right, so think about what happens when a loop runs over again. Let me show you what actually happens here. So there is a difference. Look at the curly brace. That's why it's different. So remember when I said the while loop will repeat whatever's inside the curly braces? You know what it also repeats if you do this line right here?
So,
It repeats, yeah, assigning it to 0. It repeats creating that thing and setting it to 0 every time it goes through the loop, right? So if I run this, oops. I even get a compiler error because I'm using it outside. I'll do 2 examples of what actually happens here. Let's just roll another 20-sided dice 5 times. Okay, so my dice in hand is 5. My total result is 0. It's 0. All right. I just look. When you create a variable the first time, it just says, it's whatever. I don't really care what it is. So total result is 8 now, right? Okay. So where does this go next? Where does that yellow arrow go? What line number does it go to? Right here after 45. You can see. I can't do.
Gonna check your while loop.
So where does it go from here? 45? What line?
35.
35? Okay, cool.
let's give it a weird number.
What happened to that variable? It turned gray. Do you see that? It disappeared. So the important thing to know about stuff inside curly braces is that if you ever go outside of those curly braces, everything inside the curly braces that's a variable goes away with it. It's like a package that comes with that curly brace. So when I go in here again, total result gets assigned to 0 again.
Killed it.
Okay. So see how it's 0? It was 8, but I just assigned it to 0 because the loop restarted again. And every time I go through here, oh, it's 14 now. Cool. Ah, shit. I lost it. It's gone. It turned gray, basically. And now it's going to be 0 again. Right? So it's going to repeat that over and over again. All right? So like whatever's inside the loop gets run over again. So I can't put that variable inside there. Here's another rule. This is kind of an interesting rule. If you have a variable declared inside curly braces, you cannot access that variable outside of these curly braces here. You can access it as long as you're in between here. As soon as that little yellow arrow goes outside of these curly braces, none of these variables exist anymore. They vanish. They get abducted by the compiler. They just don't exist. They're vanished. They're as if they never existed in the first place. And you know what that means is that's why here, this little squiggly, that's why that squiggly shows up. Because where is this line? It's outside those curly braces, right? Does that make sense? So I can't access what's inside here because they only live. This is basically where they live. This red squiggly is because, hey, I don't know about a variable called total result. It's like, what the hell are you talking about? There's no variable called total result. Even though it's like right there. It's like 6 lines above it. It's like right here. Problem is, it's as if it's looking at it like this. Right? It's looking at it. You don't know what's inside that while loop. So see how I minimized it? You as a programmer don't know, as well as C++ doesn't know what's inside that block. This is what C++ sees when you're writing stuff inside curly braces. It just sees a while loop. It's like, I don't know, whatever's inside there. And that's why that thing is squiggly. There's nowhere in this file that says total result. Okay? Same thing for this if statement. Again, nothing inside that curly brace it knows. So let me do a little bit. Does that make sense? So let me do another example here just to make it clear because you'll run into this error. So that was the homework, by the way, is to basically add them up and do the dice roll like that. I'm going to do one more example here. Okay. This is safe, right? Can I do this line here? No, right? Where does this have to go? What lines can this go on that make it valid?
Bracket between two variables.
Like here I can do it, right?
Yeah.
And here,
Yeah, 'cause it's still in the bracket.
and here. Can I do it within here? Oh, I can't. Why does that make sense? Why can I do this here?
You can still call.
Because it's still within the curly braces here. When I say curly, you have to think about it like inside. It's actually inside those two, yeah. You can't be out. This can't live outside of the curly braces that I declare it in. So this thing, as long as it's in between, anywhere in here, it doesn't matter where it is. As long as it's in between the curly braces here, you can use it. So I can use it here. I can use it here. I can use it here and here, and I can also use it here, because this is still within the block of code here. Okay. What about variable C? I could do it there, obviously, because it's right next to it. Can I move this here? No, because it's not within the curly braces. Okay. That's called the scope of a variable. This is the name of the technical term for it. The scope of variable B is between lines 12 and 22. You can only access it between those two lines. The scope of variable C, if I put it right here, what lines is the scope of variable C between? 16 and 18. That's it. That's all you can get it between. Okay? That's variable scope. So that variable only lives within those curly braces. Okay. And you can use this to your advantage, because when it comes to programming in games, this kind of thing is the type of information that separates the really great programmers from the okay programmers. Understanding the lifetime of variables. It's important because you're going to be declaring a lot of sometimes big variables, and you don't want them to live forever. Like, here, let me show you an example of what I mean by memory. This is going to be a little tangent here as well, but this is going to give you some insight into why you need RAM for your games. You guys ever have to upgrade your RAM just to run a game? Wonder why that is the case?
I did do all that when I started streaming on MLG because my computer couldn't hang for frames per second.
Oh yeah.
Just for the settings on the dang channel.
So if I do this, let's see how much memory this program is taking. I think it's called Project One. Project One.exe. Can you guys see that it's taking 748 kilobytes of memory? It's pretty tiny. That's how much memory it's taking up here. So let's just have this thing take up a lot more memory. Oh, I need to do this. Oh, you know what? It's running in release. I'm going to have to do this. Okay, so can you guys see now my the most expensive program I'm running right now is this thing that I created. It's taking up a gig of memory. I can have this thing take up 2 gigs of memory too. Oh, it can't deal with my 2 gigs of memory. We're gonna have to do this twice. This is a sneak peek of next week's while loop or for loop behavior. I ran out of memory. I'll just show you guys this with this simple example. Let's just take up 512 megs of memory. So the reason why this is important to know how memory usage is handled is that even a simple program can take up a huge amount of memory. And depending on how much you do and the lifetime of those things, that memory will stick around as long as your program is running. Right now I'm running 512 megs. And if I wanted to, I could take up more. I could take up to a gig. And maybe I can do memory hack 2. I'm going to take up 2 gigs here. Keep running out of memory. Oh, because I'm running in... Yeah, hang on.
If you add a potato, I'll probably add a couple more.
Yeah. So now I'm taking up 2 gigs of memory here.
Holy crap.
Let's just try taking up... I think I can take up 8 gigs of memory. This is going to be really bad for this computer. Oh, it didn't even let me do that.
That's on fire.
It really didn't even let me allocate that much memory. So the reason why I'm bringing this up is that the scope of a variable also directly influences how much memory it actually takes up. So if I had something inside here, so I have a variable called test here. So let's watch our memory go up for a second here. It doesn't even let me do that. We'll do this. I think this is an important thing to go over because understanding why scope is not just about how much memory or how much where you can access the variable. Let's go to our project here, taking out 1300 kilobytes. Let's step 1 time here. Now it's taking up 2 kilobytes. Can you see? Then as soon as I go here and exit, as you're running a program needs more RAM or not. Like if you load into a map in like Call of Duty or something, your memory usage actually goes up. So I have 1 kilobyte of memory here. I'm sorry, you guys can't really see that, but it is. And then, oops. I have 1 kilobyte of memory used here, 1,288 kilobytes. I'm in step 1 time. Now I'm using 2,324 kilobytes. Imagine it's like me loading a map. And then I step, and I'm back down to 1,000 again. Okay. The key is that the lifetime of variables can be scoped to be within curly braces as well. So you pay for that memory as long as you're inside those curly braces. So if you have a program, all my memory hacks, that looks like this. You pay for variable here, you pay for the memory here, as well as here and here. Right here between lines 16 and 19, that's when we take up the most memory in this program. As soon as we exit this and we go to line 24, we get back the RAM that we used between here and here. Okay? That's why it's important to know the scope of the variables. That's why as you get more and more time spent programming, you have to be clear as to when you want to scope your variables lifetime.
So like when you're nesting stuff inside a loop, does that mean you're taking up more memory?
Yes.
Okay.
But I say that, and I'm going to say this with a caveat because for the most part, 99.9% of the time you're programming anything, that's not going to matter. But the 1% time, like the 0.1% time when you're trying to get back memory usage on a console, you want to be very careful about how you're allocating memory. There's ways you can allocate a ton of memory really quickly, just like what I did up here. If I make this thing, this is me allocating 1 gig of memory right here. This is like 4 gigs of memory right here. You just have to know when you're doing stuff like this to understand that, okay, this thing is going to be alive for as long as I'm inside here. This is kind of a special example, though. I'm using a pointer where normally you do this, something like this. This is pretty common for cases where, let's say you want to store player name. Like, let's say you ask for, like, hey, what is your player name for WoW? In a lot of older engines, a lot of older games, you'll see something like called like player name, and they'll allocate something like 1024 characters for that thing. This is allocating 1024 characters for your player name. And here's I'm putting it in. If you made this thing 2048 character, like depending on what the character limit length, like some games have a limit length of you can only name a character 20 characters. Some only name them 30. This is the kind of thing where it comes into play, where you only want to do this kind of thing once, only the place where you're using it, as opposed to doing it like outside here. If you move that outside, now everything is paying the cost of the player name, and you're going to be paying that cost forever, basically. All right, so let me jump into the lecture/lab work. So I wanted to give you guys this homework last week, but the lab work was pretty much what we ended up having to do. I want to go over the midterm questions real quick, just so you guys understand what the midterm is going to be about, so you're not caught off guard. And I want you guys to spend time in lab today, because I'm about to end class here in about 10 minutes. So I want to go over the midterm real quick, and then also have you guys do some lab while you're here. Okay, so a lot of these are like the first couple pages are from chapters 1 and 2. Some of these things are actual exercises, just kind of review, hopefully, of things that you'd want to do. Like what is wrong with this loop here? Like what actually happens with that loop? I'll give you guys some multiple choice questions on that. Like what actually prints out when you run this code here? So if I have like int k equals 8, do this. The things that, yeah.
So I was looking over the questions. Are all the questions on the midterm going to be multiple choice?
Yes.
Okay.
They will all be multiple choice. Near the end, though, this is the part where I don't have answers for them. These are the things I kind of want you guys to put into a program and test yourself and see what the results are. Because, for instance, for this question, I give you guys an expression, and I want you to say whether it's true or false. It's kind of like what we just did in class, right? I'm saying that x is equal to, it's kind of like math problems in high school. X is 300 here, y is 250. Is that true or false? You tell me. Is this true or false, for instance? We can just do that one. Who knows?
For the X question?
What is this? Is this going to be, is that result going to be true or false, the whole thing?
False.
No.
It's going to be false. If you don't know why that's false, write that into a program and then see. Break it down. The first thing is you have to work, the way that you solve these things, here's the way that I go about solving kind of complicated expressions, is you solve the inside of the loop first and you go out from there, okay? So this question here, is this statement true or false? First, is that true or false? False or true? This thing is true because, remember the or condition says, as long as either of them are true, the whole thing is true. So the whole thing is true, but there's an exclamation point in front of it, which means reverse it. Okay. What about this one here?
True.
Is that going to be true or false?
True.
True. Because again, you work from the inside out. Is this true or false? This whole thing is true. This and this are both true, so the whole thing is true. Okay. And there's a tricky one. Oh. Good timing. You should take this review for the midterm for next week. What about this one here? So you work from the inside out.
True.
It's either one or the other. The multiple choice question is going to be either is it true or false. A 50-50 chance of getting it right. But it's important to know how you work it through. Okay, start with the innermost. Okay, order of operations is the this is going to be. Is that true or false? That's going to be true. True and true. That whole thing is true.
No, it's false.
Then you reverse it again. It's false.
So once it goes out,
Yeah, because that one's the order of
You do the parentheses first. You guys remember you do stuff inside the parentheses first.
And then the order of operations, because the exclamation is first, right?
Yeah.
My dear head salad.
Yep.
Where they sealed that shit in my head.
Okay. So that's what the midterm is going to be like. It's going to be a little bit of like, hey, here's how do you write this program, as well as what is the result of this. Don't forget what modulo means. You should know what 15 modulo 14 is equal to. We just did a bunch of it. Does anyone know what 15 modulo 14 is?
3.
3? That's correct, by the way. So giving you as a study guide, I may switch up a few of these questions. You might not see 15 modulo 4 there, because you guys just heard it. It might be like,
Just reword it or something.
yeah, it's going to be a little bit different, but the idea is going to be the same, though, right? That's why it's important to know how you get to that result, right? Like this one here. If x is equal to 5, what is the result of this? What is x equal to?
It'll be 1.
It's going to be 1. Is 5 greater than 2? True. So 5 minus equal 4 is equal to 1. I might give you this question and say 8 or 7 or 6. Just understand that that's what the style of it's going to be. Okay, so study this for next week. There's only going to be 20 of these. There are a couple of these that are going to require you to write them out. Like, what is the result of I after this do while loop ends? Same thing for here. What is the first and last value of I? These are a little bit tricky because you kind of have to write them out. You have to go through line by line. Imagine the little yellow arrow in your head as you're reading it. Like, go literally line by line and write out each result. You'll have to write at least 10 lines of like paper and pencil. Any questions on this? All be multiple choice, but that doesn't mean that you can just guess them. I do give you one answer here for this one. How do you get a random number from the range of 15 to 40 here? Any questions? All right. So for those of you guys that want to stay after in class and do some work, you guys are welcome to. I have a homework assignment that's good for practice. This is practicing exactly what we just did. This is last week. So this is not homework because you guys have midterm next week. But this is kind of what I'm asking you guys to try to practice here. So write a program that asks the user to type in numbers. After they type in each number, you should report what the actual sum of the numbers are. As soon as they type in 0, it should stop. Okay? And next one is to simulate a blacksmith store. Present the user with a choice of things that they want to buy. And if they pick a correct answer, then tell them result. This is very similar to how we just did the dice rolling homework, right? You have a while loop that checks to see that it's one of the inputs, and you can break out of it as soon as they enter one of these valid ones. Okay. All right. So let me put this up on Zool as well. And then next week after the midterm should only take about an hour for everyone to get through and do. Maybe a little bit more. I'll give you guys as long as you need to. I'm hoping to get to some lecture next week as well because this is not homework. This is just
So this will be your lab work?
this will be your lab work.